Hello, everyone. And, my name is Yonezawa at IoT Working Groups. And thank you very much for gathering these working groups. Oh, okay. So let's start these working groups. And firstly, I briefly explain the IoT working groups. And this IoT working group is a kind of forum to share the research activities and experiments results for discussion and collaborations on IoT platforms, infrastructure, and services. So if you have any activities related to the IoT, and also if you have research results, please share such information to these working groups. And this is the chair of and co-chairs of these working groups. So I'm chair, and also three co-chairs managing these working groups. And today we invited some four speakers, and maybe you can see at the programs. And the IoT working group is two slot. And the first slot, we invited two speakers from Yonezawa, Assistant Professor Yonezawa, and also Mr. Gunji from Japan. And the second sessions, we invited another two presenters from Abhimanyu Pandey from Nepal and Samo Garis from Italy, Sweden. Maybe he's now working in Italy. Yeah, yes. Okay, so let's move to the first speakers. So please start.
Let me share my screen. And it's better to use this. Zoom is okay. Okay. Thank you very much for giving me this great opportunity to introduce our activity. So I am Takuro Yonezawa from Nagoya University, Japan. So my title is The Internet of Realities, a Future of Connected People and Spaces. So, so this is still the kind of the vision phase we are doing in some projects, and I hope I can get any feedback from you, the hint for the future activities. So let me introduce myself first. So I am working as associate professor at the Graduate School of Engineering, Nagoya University. So my research interest is the intersection of the system. So of course IoT is one of my interest, and also the data science, and I would also interested in the human. So have you ever been to Nagoya? Yeah. Okay, so I'd like to just show where Nagoya is. So Nagoya is, you can see that it's central Japan. In geographically, it is like 1.5 hours by Shinkansen. And actually, the Nagoya was selected the world's greatest place of 2023 by Time magazine. So you must see the many good things, foods, and also the sightseeing. So and also it is famous for motor industry. So Toyota Motor Corporation, headquarters of the Toyota Motor Corporation is located in Nagoya. So the Nagoya University is also very active for the mobility kind of researches. So Nagoya University was founded at 1979, and we have near to the 2,000 faculty staffs and more than 20,000 students. Yeah, I hope we can host your visit in Nagoya and Nagoya University. I actually have a bit transdisciplinary background. Actually, the major was the computer science, from the system point of view, network point of view, and the human-computer interaction. But at the same time, I actually involved some of the humanity kind of the topics like philosophy, religious studies, sociology, communication theory, and even the demonology. You know the demonology. So I actually gave the lecture in the university for the demonology. So it is like how the people's behavior is changing when we encounter the big trouble, not only personal trouble, but in the social situation is very bad. So demon will be the happening. So yeah, this is my disciplinary background. So I am working. So by combining my this kind of experience, I am working several projects, not only the pure computer science research, but also I am now working for the research that prevents the social isolation or loneliness. So I'd like to show that later. Okay, so today I'd like to, so I have 1 hour, it's too long, but I'd like to introduce 3 topics of my past experiences. The first one is the directly relating to the IoT and also smart city activities. So I was working as the project coordinator, the kind of the leader in the European Japanese smart city joint project from 2013 until the 2018. So then I moved to the Nagoya University, and then I continued to the research about the smart city topic. It's called the City Feder, the Dynamic Federation of Smart City Platforms. Then I'd like to introduce our current activity called Internet of Realities. Okay, first I'd like to start from this topic. So I've been working with European cities and also the Japanese cities to making the common architecture for the smart city. So many municipalities are involved in our project, also the industries and also the academias. So one of the main topic at the smart city project was how we can get the sensor information from all over the city. So one straightforward approach is, okay, let's deploy sensors to the cities. So one very famous example is the Smart Santander. So in Santander, Spain, there are many sensors installed, like this. So this is, yeah, okay, we can get very fine-grained information from the entire cities, but you can easily imagine it is very costly in terms of the installation and also the management operating. So our idea was how we can create more sustainable way to get the sensor data from all of the city with cheaper cost. So our idea is using the garbage truck as sensors. So we put the environmental sensors or camera into the garbage truck, and we found that the garbage truck is the best mobility in Japan that covers the entire city in comparing with the other public vehicle. So we confirmed that we can cover the more than 98% of whole road in a city in 1 week. So by comparing the mobility, that may be up to the 50% of the entire road network in several months. But by using the garbage truck, we succeeded to collect the many sensor data from the entire city. So this is visualizing the PM 2.5 data from the one day. So this is the we tested in the with the Fujisawa city. We also still are working this kind of project. So of course, not only the environmental sensors, we actually collect the number of the garbage thrown in each area. So this was done in 10 years ago, but we try to collect number of the garbage thrown from the city. So by replaying the information, so this Pac-Man, yeah. So each Pac-Man means a garbage truck. So this is a replay of the one day. So you can the right chart means how much garbage are collected in each area. So now you can compare how much each area has how amount of the garbage in a day, and we can compare with yesterday's situation and today's situation, or we can compare the different areas. So by collecting and visualizing and comparing this kind of information by leveraging the IoT sensors with the mobility, we can use this kind of information for urban planning or the behavior change for the citizens, etc. So like this, we come up with several idea for collecting the sensor data from the entire city with the sustainable way. Not only the garbage trucks, we would like to also combining that activity into the daily routine works for the city officers, and also we leverage the existing web information as sensors. So also we try to use such city information for marketing use. For example, you can imagine that so this in front of this display, it shows your face, and according to your face, this coupon provides the good deal. So you can make a good smile, you can get good deal. So you can take a photo, and then you can use that photo as a coupon. But in the background of the system, this system is using the city sensors. So if it is raining like today, so this deal will increasing. So because the behavior change need more power to change people's behavior. And if that area is very crowded for the people, that we can reduce the percentage of the coupon. So actually, we deployed this sensor in several cities in Japan or in Spain, and we confirmed such impact.
Santander inicia una campaña para potenciar el turismo en la ciudad. Se llama Tu sonrisa tiene premio. Con este dispositivo, el visitante puede medir.
But yeah, let's skip. So that one of the outcome of this project, not only the technology, but the community, international community. So now we are organizing the non-profit, the international organization called Urban Technology Alliance. So like currently the more than 40 or 50 the organization, including the cities, industry, academias, are involving our organization. So if you are interested in, so the idea of this NPO is exchanging the lessons learned in each project, and or the sharing the test bed of the city to replicate the product or activity of one city to the another city. So yeah, and then also our some of the software is open sourced under Eclipse Foundation. One of the product is called the SensiNact. So SensiNact is very related to the IoT sensors. So because there are many protocols. Maybe you are a professional than me. Bluetooth, the XMPP, MQTT, a little bit that layering is mixing, but so there are many the protocols, the interfaces. So there are the semantic or syntactic differences. So this is maybe the common idea for everyone. So we'd like to making the adapter for exchanging such the different protocols. So this is the southbounding bridge and the northbounding bridge provided. So this actually requires the much engineering cost. So we provided such the adapter to fill the gap between the different protocols or IoT things. Okay, so the second topic is the city feeder, so dynamic federation of smart city platforms. So as you know, Japan is the country with full of disasters. So we have the earthquake like every day. We have typhoon every 2 weeks in the summertime, and also some of the full things are happened, but so the motivation of this project is how we can share the data. So there is some of the levels, how much we can open the data. So there are several policies. For example, okay, so this sensor is free open, so you can subscribe anytime. And also this sensor is closed use, so only the limited company can use. And also there is a paid data stream. If you pay, you can get that data stream. But we focus that there might be the situation when we are in the special events, like a festival or disaster or the pandemic. For the public purpose, we'd like to share that information from each cities to the another cities because that is very useful for such emergency case. But so in that case, we assumed that the agreement must be done by the manually between the different cities. So for example, when the extreme raining occurs, the Tokyo can provide the traffic sensor information to the different cities, different regions, and also when the flu infection is very increased, I can share the human mobility, human flow data. So this means that it is better to control the data flow automatically based on the social context, social situation. So like when if there is something happening, so normal case is we cannot get any data stream from the different cities, but if the situation is happening, we can get the data stream. So this is very basic idea. But so the goal of our project was designing the meta architecture that enables easy interconnection between smart cities according to the social conditions. So we call that it's a programmable federation architecture. So for that case, this is a typical use case. So in Japan, we have a different emergency level from level 1 to the level 4. Level 4 is everyone have to evacuate to keep your life. And the level 3 is like elder people or the small children have to evacuate, etc. So in each emergency level, we can set the level of the openness of the data. So that means we'd like to dynamic access control to each data stream according to the social context. But there is the key question: how can we make common understanding of social context? So it is easy to understand there was the magnitude 7 earthquake happening. That was very clearly understandable, defined things. But you can imagine, okay, so we'd like to provide our data when this area is so many clouded. But how we can understand the cloudness of the cloudness level of the each region, because you know that in Tokyo every day very crowded. So that definition of the feelings of the social context is different to the each people. So we need to have the common sense or common understanding of the social context. So we think the transparency of the definition or the logic to capture such social context is very necessary for our project, and also this leads the verifiability of our system. So data source or logic to recognize the social context is one of our main challenge. Okay, so we prepared a server called the City Fader. And also the programmers or developer or even the city planner, city manager can define or making a logic to recognize the social context. So we use the non-code interface to modeling such the social events. So right now we use the Node-RED. You know Node-RED is the non-code, the simple programming toolkit, and we registered this social context definition and the logic to modeling to the City Fader server. So that City Fader server automatically try to recognize the social context, and if the social context are happening, we notify that context to each cities. And also it provides a catalog of data and the access method. Like you can access to this data source with HTTP or MQTT or whatever. Then based on the combination, the data providers and data receiver can access to the automatically. So this is more detailed version. So in City OS A and City OS B, so in this case, City OS A provides the data when in the social context, under some social context, and so it first provides the social status registration and data catalog registration, they do, and also the City Fader server monitoring the social context by the following that definition, and also the when the event is happening, automatically the functionality of each city OS is changing, and we can get the social data stream, sensor data stream from the directory the City OS A. Okay, so this is actual implementation. So we provided the social context. So this is a list of the social context. There are many definition of the social context by modeling the by Node-RED, and this is inside of this City Fader server. So this City Fader server, so each OS, each city OS provides the modeling result to the city server. So in the City Fader server, there are many definitions are defined and operated, and then we can access this city social context by using the RESTful API. So the result of the city context is provided by the binary information with the associate the URL. So this is the typical example. So in peacetime, the evacuation place of the information is not provided, but once disaster happening, the inventory information is automatically shared by the local or the near community or the cities, and then in emerging case, these information are used as the open data stream. So this is very a little bit difficult to see, but you can check. So we use the fireware, one of the common smart city platform in Europe. So firstly, so this user cannot have does not have the access to the data stream. So access control is off. But once we get in the the typhoon situation, so automatically that access control is changing. So now when we refreshing the web page, we can check that access control is automatically on, and then we can get the actual data stream in each cities, the different cities, the system. Okay, so these are the just background how what kind of things we are involved, and from this, I'd like to introduce our concept vision of the Internet of Realities. So this is not Internet of Reality, but Internet of Realities. That means reality is not one single. So this is our consideration. We have different realities, right? So how we can connect our different realities is our mission. Okay, so this is the terminology definition to share the same thinking baseline. Okay, there is a fact. The fact is the universal truth that can be verified through observation and experimentation. Like you are in Japan, you are in this room. Okay, that is a fact, right? But when we encounter the fact, but reality, we have the different realities. For example, if you are first time to come to Japan, maybe this is a very unique experience for you. So your emotion is the changing is much bigger than compared with the Japanese people. I lived in Yokohama for 18 years, so this is my neighbor place. So maybe I have the different feelings, right? So that means reality is more subjective things. So it is understanding and interpretation of the words shaped by individual perception, experience, and social consensus. So, but we think that our reality is now becoming more diverse. So when I started the Smart City project, I only regard the physical world as reality. So I try to make smarter world of the physical world. But currently, our reality is not only the physical spaces, but our reality is expanded to the virtual world. And also we have kind of the concept of digital twins or virtual reality or metaverse. So I guess that you are still living in the smartphone space in 3 or 4 hours in a day. That means in such time, you are maybe separate from the physical reality. So some of the younger generation spent 100 hours a week in virtual reality space. So this is the reality of the younger generation. Even they are sleeping, they are wearing a VR headset. So I interview with such young people, why are you wearing the virtual reality headset when you are sleeping? So they said, we had just an event, the sleeping together in the VR chat space. So we can hear the other people's sleeping noise. So that is the one of the interesting enjoyment time for them. Yeah, so this is the reality. And also the generative AI provides very realistic world. So you can imagine that, so this is the OpenAI Solar's generated the virtual world. So this is very realistic. So maybe soonly we can get the 3D model of this kind of the real world, and maybe we can dive into the real world by wearing a headset. And also, so this is another example. So as you know, only one shot, one photo, the AI generates that video. So this is actually not real things. So this is me, this is my boy, this is my boy, and this is grandpa. So actually, these are the fake. But after seeing this video again and again, I am a little bit feeling, okay, there might be this kind of things was actually happening. So I'm feeling that my memory, even my memory is just rewriting, right? So in that sense, that our reality is becoming even more fluid, very dynamically changing, and also individualized. So in that sense, so we have the fact, and we have different realities. It is the same, but the distance of our reality is more longer than past because of the impact of the information technology and AI. So our motivation is, okay, how we can share or how can we connect so such long distancing realities for common understanding, for example, mutual understanding. So this is like intersubjective things, a worldview or values shared among people. To do that, we have different challenges. One is the reality embedding, how we can model, how we can understand our reality in the calculatable way. And the second one is how we visualize or hosting our reality. So just hosting the information as a web page with the HTTP server, how we can host our reality or visualizing in this internet architecture. And the third one is how we can making a network between the different realities. So to tackle these challenges, now we are doing the different projects. One is the JST Crest, the Internet of Realities project. The other one is more, we'd like to leverage our technology for solving the social problems like social loneliness or isolation in the JST Listex Amplater project. Okay, so I'd like to a little bit details. So first one is reality embedding, the method to formally represent subjective and intersubjective realities. This might be the synthesis of the IoT data. It's more objective data, and emotions, our internal status, it's a more subjective data. So by combining this data, I would like to get the reality embeddings. So the second one is reality presentation and hosting. What is the effective ways to present our diverse realities to users individually and collectively? And the third one is reality networking. So underlying infrastructure that can distribute, align, compare, and unifying these complex representations. So I'd like to show some of the example what we are doing. So first one is how we can present our reality. So this is just one example. So this is not the answer, but just the example. So you can see, so this is just a web page. So you can access by using your smartphone. So this is a hotel I just stayed. And yeah, this is 3D space. And just besides of the room, there is a conference hall, lecture hall. I actually gave the lecture in the day before yesterday. And also this is my apartment. So you can also easily to go to the, and this is another place. So this is the Oiso towns, the place I am working with. And so this is my grandmother's house, right? So you can imagine that usually digital twin is reflects the physical world as it is in the digital world. But this word is based on my experience, right? This is my personal realities. And also, so other guys can go to the MySpace, and when we are making the handshake with this guy, his reality is transformed into the my reality space. Then maybe the new model is inferring based on his experiences, his reality. So this is the laboratory of his environment, laboratory he is working. And also, there is even his private room, maybe, yeah. So this is his room. He's living here, right? So if we have telepresence robot here, we can also dive into the telepresence robot. So we can physically connect to this space. Okay. So this is just one example. So actually, so this is the based on, so we are collaborating with the Carnegie Mellon University. So actually, this has many technical advancements. So we are combining different techniques, internet architecture techniques, and also the IoT techniques. Using PubSub, so we use the MQTT, and also as a web platform, we use the WebAssembly for providing the scalable architecture. So so this is another example. So this is a reality networking. So we also developing this kind of a new robot that can connect the different space. So this robot has a spherical display and 360 camera on top of the display, and this can move. This can move. So this is we designed for inclusive group telepresence, not for single use. So this is the group presence. So I'd like to share the video. So we call this is a meta portal. So in this case, we put this robot the different physical space. Then we can communicate the space-to-space communication. Also, we can dive into the robot by wearing a headset. Then you can see the surroundings, right? So this is a physical world to the virtual world communication. Okay. So and also we can put this robot in the metaverse, and this robot is connected to the real world. So we put the same robot in the physical world or virtual world, the same location. So then we can connect the different spaces by using this kind of the immersive way. Okay. So you can imagine that if you are some of the very event, maybe we can provide the remote tour, right? Remote tour. So you can join this robot from different countries, but you can share the experience with the others. And it's like a bus tour, a remote bus tour. So you can share the same experiences. That may connect the friendship of the different people. So here is the very typical telepresence robot. This is actually product. So this is good. This is good. But you can imagine that it's okay for first 5 minutes. But suddenly you found that there are some isolation feelings is happening, because the relationship between the physical world and the virtual world is not constructive. So, so we would like to provide end-to-end relationship between, that means the space-to-space or group-to-group communication. It reduces the isolation feelings, and also it provides it enhances the shared experiences. So also we have some crazy devices. Not only the robot version, we can also wear our robot. So we can provide our body as a mediation of the different spaces. So so this is me, but this body is my friend's body. So I can dive into this robot remotely. So, and not only me, the other people can simultaneously dive into his body. So we can share the experience with different person. Okay, so this is the first prototype, just combining several iPad, and this is second prototype. It's a 3 millimeter pitch LED, and now we have a third prototype with a 1.5 millimeter pitch. So actually, there is the XR glass inside of the display. So this guy can also see the surroundings. Also, they can communicate with the different persons. So this is another version of the Meta Portal. And third one is the reality embedding. So this is a little bit difficult, the research challenge. So how we can understand the human realities. But we had the experiences over the smart city. So we actually started to how we can understanding urban realities first. So this is the difference of the urban facts or the urban reality. So that means how can we understand each area and what are the characteristics of these spaces. So as a fact, it is objective features. We can compare, we can recognize these areas in terms of its size, structure of the population. But reality is more related to the subjective feelings, just as I say. How do I, or how do you feel in each area? What does the space mean to us? So, for example, if when you're going to this area, for some people, this is a working place, and for some of the people, this is the shopping places. So, if we can understand the urban realities, we can use such information for many use cases, like typically it's marketing, for example, advertising, but also we can maybe connect that information with the what kind of the mobility, what kind of a service is needed in each area. So if there are many diverse people are there, we should provide kind of translation service in there. And when we are in the pandemic case, we have to close the high diverse area. So to do that, we come up with the urban area embeddings. So based on the word-to-vec architecture. So this is vectorizing the area, each area's functionality, like the word-to-vec that did. So then we actually confirmed that we succeeded to grab the feature of the each area just by using the human's mobility data. So this is the GPS data from the 23 million users. So we did not use no demographic information such as age, sex, job, etc. And then, so actually we opened our machine learning model result in the public. So you can check our paper and also the GitHub. And so you can actually use our embedding result. So then, once we collected calculate each area embeddings, then we try to model the human's behavior. So I'd like to skip the details, but we succeeded to separate the different types of the people. So this looks like the office workers' activity in a day, and this looks like the homemakers' activity in a day. So data source is the same, but we can separate the based on their reality. Okay. So then we also try to understand the diversity of the area. So how diverse people are there. So we actually calculate the main cities of Japan, and we compare the what kind of the diversity is there. So actually we compare the before or under the COVID-19 issue pandemic. So this is the Nagoya city's the diversity information. So high diversity means the red color. Red color means high diversity, and blue color means low diversity. So you can see that in the daily peaceful time, so the center of the area looks high diversity because many people are working here, and so this is the center area. But under the emergency situation in the COVID-19 pandemics, we found that the most of the areas diversity are reduced as low. But you can see there still remains the several high diversity areas. So then you can imagine that yeah, we have to close such area to reduce the infection of the COVID-19 cluster by cluster. Okay. Okay. So last topic is the preventing social isolation and loneliness. So we use how we can use our concept or our technology to prevent social isolation and loneliness. So actually, Japan is the most loneliness country in the world. So this is the survey of the OECD. So this is the proportion of responders who rarely or never spend time with friends, colleagues, or others in social groups. So surprisingly, Japan is #1, right? Japan is the most lonely people are there. And actually, this is the more recent survey by the government. And so usually you may imagine that loneliness is only the problem for the elder people. But reality is younger generation feels more loneliness. Maybe it is a little bit hard to understand because they have the smartphone, they join the social network, so they connect the many friends every time. But actually, it may enhancing the loneliness. Maybe one reason is they compare their status with the other people's. So when we see the social network, there are many gorgeous photos, right? The people are enjoying their life. So it maybe affect to our loneliness. So, and the other important fact is that near 40% or 50%, like half of Japanese people actually sometimes feel the loneliness. This is very big, the impact, the fact. And also, the sum of the research actually reveals the healthy risks of social isolation and loneliness. So now, so many article reveals that the loneliness is the most serious epidemic of our time. And actually, the lonely people have a 50% increased risk of premature death. It is even equal to the smoking 15 cigarettes per day and being the alcoholic, right? So it is higher than not exercising and twice as high as obesity. So even you have the exercise, right? If you are lonely, maybe that bad influence is much bigger than the exercise. Some of the research said so. Okay, it raises the risk of coronary heart disease by 29% and the risk of heart attack by 32%. So also, lonelier people decline cognitivity at a 20% faster rate than those who are not. And the other case is, okay, I am not lonely, so this is not my problem. Maybe you may think so. But lonely people refuse the social relationship, and also sometimes they think they are more aggressive to the social relationship. The aggressive means that they're more violent action may sometimes happening when people are in the very high loneliness. So some of the accidents are happening in Japan also. One of the reason is maybe the loneliness of the people. Okay, so to solve the problems, we are now creating the system called Community Compass that enhancing community awareness for ambient engagement. So actually there are many communities. It's some of them are actually volunteered communities, but you may don't know what kind of communities are in your city, right? You can see that, okay, there is a station here, there is a supermarket here. So such kind of things, they are related to your daily life, so you know. But you may don't know what kind of community are there. So to enhance such community awareness, we are creating the system called the Community Compass. So we also integrate this system into the daily life. So one of the example is, so in Japan, we do the health check once per year or once per the semesters. So this is for health checking. So first, you can measure your weight, and you can check the body composition status. So how much muscle you have, how much fat in each case. So maybe you do this kind of body checking in several times per year. Okay. Then the result is shown, so printed. So this is just the result of your body. But we combine this result with the related community existing in our region. Okay. So actually, I'd like to show my result. This is very private result, so you do not take photo, right? Okay. Okay. So I have 180 centimeters height, and I am a little bit fat, and I have this kind of muscle, and we use the LLM. So just providing this information to the LLM, and which local communities are good for me. Please introduce that community with its reasons. So this is the result. So this is actually based on the real communities existing in our region. So one is, this is my Chinese exercise, right? And the second one is, I was a little bit surprised, mountain rescue team. So the reason is very interesting. So okay, you have a height, right? So you can see the evacuating people that suffer from the accident. So, and also you have good body. So actually, I had experience with a marathon in my younger generation. So that the experience is still remaining in my body composition result. So it is said you can good at mountain rescue, and also the diving club. So you have small risk of the dehydration based on my body composition. So these committees are recommended. So this kind of things is I never imagined, because I don't know. I actually didn't know there is a mountain rescue team in our region, or there is a diving club in our region. But once we actually, I found my objective, the body composition, in some sense, I am ready to receive the new information. So from this recommendation, I am feeling, okay, it might be interesting to join such kind of community. And also, so this is recommended by AI. So if the person-to-person recommendation, maybe there might be the influence to the human relationship. Okay, let's come to my community. So I'm feeling, okay, I want to go I don't want to go, but if I refuse, maybe he angry or something. So this human relationship is sometimes very critical. So, but we can take, so AI can take the responsibility. So this is the, I guess this may work. Okay. Also, we can combine this kind of the community compass mechanism in our integrate into daily life, like receipt. So when you buy this kind of items in the supermarket, you can imagine that, okay, so this guy or the lady maybe raise the baby, right? So we can provide the information of mama and papa circle community. And this looks like, so this user buy the protein, right? So you can imagine that, okay, it is good to provide muscle club, right? So the important thing is how we integrate this kind of system into our daily life, right? So this is also the Internet of Realities challenges. Okay, I'd like to finish my talk. So Internet of Realities, we have the vision and challenges. So we'd like to help the people better understand those who are different from themselves. So this isn't just about exchanging information, but it's about creating a new form of the internet that allows us to respect each other's thoughts, experience, culture, feelings, and work together to build a happier society for everyone. Okay, that's my talk. Thank you very much.
Thank you very much for a very interesting talk. And we have some times for the question and answers. And do you have any questions? No. Yes, please.
Thank you very much for interesting talk. And do you have any idea for monetizing your products? I mean, for example, your virtual metaverse glass and so on. How do you think about it?
Yeah, yeah. Actually, some of the companies interesting to our research. So, like, and also the rising countries like Israel, the venture companies are interested to our services. So because there are some in the like the south, such kind of oil countries, there are many big events. So they would like to use our robot for remote participants, and also we now would like to, so we had the intellectual property of the Metapole. So we'd like to export our idea to the US. So now one US company tried to find the partners to monetizing our idea. But I am a researcher, and I am doing the new things with students. So I personally do not have the intent to do the monetize by myself. But yeah, I'd like to find the collaborators always. Yeah.
Thank you very much.
Thank you.
Thank you for your presentation. I really like how you leverage the AI to connect with the data and process, especially your physical health check, the other one, the BMI, and the data suggestions. Is there any other wild experiments with the AI in your past year or two that you were saying you didn't share here, but it was wow, that's cool.
So actually we tested the different model, like starting from GPT 3.5, GPT 4.0, and I do not check with GPT 4.5, but actually, without any fine tuning, AI recommended some community with the reasonable reason. So that was actually we were surprising, but in some cases there are some the recommended community that should not be recommended for the specific users. For example, if you have kind of accident in your foot, you have some of the community activity affect provides bad effect to your body. So it must be checked by a medical person. So sometimes the AI recommends contains some hallucination. So yeah, in that case, yeah, we should check that our recommendation result is actually recommendable or not. So that is current limitation. So in that sense, we are now working with medical people, and yeah, and also that it is important to work with the community people. So the some of the community are very open, so they are welcome the many people. But some of the community has no human resource to accept the more people. So in such case, our project have to collaborate with university, industry, and municipality, city, and community, local community, and also citizens. So this is so this is also the reason why we are doing this kind of research, because we have the responsibility as the bridging the different organization, community, or the municipality or industry from the fair point of view. So yeah, still there are many challenges. So we are now tackling those things. Yeah.
Thank you very much. Any other questions, comments? Okay, so it's time. So thank you very much for your presentation.
Thank you very much.
And let's move to the next speakers. And the next speaker is Mr. Gunji. And could you show your presentation slides here?
Yes.
Okay, I can see.
Okay, displayed?
Yeah, but is it possible to full screen?
Yes. Okay.
Okay. Okay. Please start your presentation.
Okay. Hello, everyone. My name is Yoshimasa Gunji. I'm very happy to meet you at this meeting. Today, I'd like to talk about the field experiments. The title is Smart Village Application over the Private LoRa Mesh Network in Sri Lanka. This project is founded by Asia Pacific Telecommunity. Let me introduce myself. After working as a radio communication engineer in Japanese company, I joined the BHN Association about 10 years ago. The BHN is an NPO organization satisfied by the Japanese government. Telecommunication is one of the basic human needs. Based on the concept, we are promoting volunteer activities to support regions and countries that have not benefited from telecommunication technology. Now let's move on to the main topic. The first, I will explain the background of the Sri Lanka project. Sri Lanka is a beautiful with long history country, especially in rural area. There are beautiful rapid rivers. However, sometimes floods cause great damage to the country. The second problem is the loneliness of the elderly and pregnant mothers. During daytime, young people live to work in the city side, while they are left alone at home. They have no means of sending out emergency alert. The third problem is the transformation to smart agriculture. Tea is especially one of the most important industries in Sri Lanka. It is necessary to transform from traditional agriculture into smart agriculture by utilizing data. The purpose of this demonstration project is to solve those three problems mentioned in the background by utilizing a sensor-based nervous system. The basic ideas for proceeding with this project are following 5 points. The most important is the network must be work in disaster and also in normal time work for residents. This is very important. And the second is using no custom design equipment. This diagram shows the project from an IoT perspective. The core communication network is sensor NavNet. Sensors that detect various events are connected to this network. And this information is accumulated as a database. Using this data, for example, flood alerts are sent to residents, and if necessary, emails and SMS are also sent via the internet. And the database will be analyzed and utilized for tea cultivation and factory productivity. This diagram shows the configuration of the system installation in Sri Lanka. The system consists of 2 major blocks. One is the sensor nervous system, and the other one is a consolidated data and action determining computer. About sensor nervous system, the system is composed of 10 radio stations connected by LoRa mesh. ID1 here, this is the key station. ID3 is a loudspeaker station. ID4 here is tea factory stations. In here, one oxygen sensor and one weather sensor are connected on the station to measure the environment of the tea factory. ID2 and the ID5 and the ID6 and ID7 are alert call stations, colored red color, for lonely elderly and preeminent matter. And ID6 is also functions as a loudspeaker station for people in the surrounding area. And ID7 here connected to a weather sensor that measures the environment of the T fields. ID8, yes, here, in blue is the Mahaway River water level sensor station. And IT9 and IT10, they are repeater stations. Here, the consolidated data and action data mining computer is a computer system that uses the database collected by the sensor navnet system in many ways. For example, it can send emails, SMS, and voice message, or provide long-term data for various analysis. Today, I will explain this side, the sensor navnet system painted in yellow. This is the system layout on a map. The location is Elptia. The India, Sri Lanka, Elptia is here, 90 kilometers east of Colombo. The tea plantation and houses are scattered in the forest of large trees here. The office and factory located here, and key station and tea factory station are located in the same time, same place. The Mahaway River flowing here, and river water level sensor station is located side of this river. The 4 alert call station, 1, 2, 3, 4, are shown like this. And this alert station, Bangalore 02, has a weather sensor, measures the T fields. This diagram shows the configuration of the software of sensor navnet terminal. Hardware is Raspberry Pi and OS is Raspbian. LoRa network and database control software runs on the Raspbian. The part of surrounding by the red line here, this is the core of the sensor navnet system. So we call this is sensor navnet OS. This green part is application software field. It is created using Node-RED here. Sensor and alert operations are performed on this application software field. Using this construction, it is easy to develop application software without to develop complex radio network with database functions. Navnet is a network control concept, and this is developed by NICT in Japan, and Sensor Navnet OS is provided by Nashua Solutions Corporation. This diagram is an actual implemented Node-RED flow. I think it is no need to explain. By connecting the function nodes lined up in the palettes, easily, you can create variety application software, including communication in LoRa mesh. This is a radio communication method. Low-speed TDMA is using on LoRa mesh. One frame is 60 seconds, and one slot is the 6 seconds. The slot position of ID 1 to 10 radio station is allocated like this. Time management for this TDMA is done by Raspberry Pi's clock, calibrated with GPS. This table shows the communication speed of LoRa mesh. We adapted spread factor 7 and error code rate 3 here and here, and we're using these parameters. With these parameters, the actual payload communication speed calculated can be estimated about 2.4 kilobps. In the communication is possible up to level about minus 123 dBm. This figure shows the configuration of LPTR key station. The left side is a sensor navnet terminal. One Raspberry Pi is using here. And this Raspberry Pi has a database from the sensor stations. This green is LoRa module, and this one is the GPS module. And all stations, not this LPT, all stations are using battery backed up power supply. The consolidated data and action determined computer communicates with navnet terminal via this Wi-Fi router using SQL command. This is the major component of LoRa radio module, very small. The USB, we're using USB connection, and the radio frequency is 920 megahertz band. The major specifications are described on here. This diagram is the actual call. This are the alert code for aged person and weather sensor stations. This is the same as LPTR key station. This one is meteorological data sensor. In this time, illumination of sun, rain gauge, air temperature, and humidities. And this red portion is using for alert code. This is receiver, this is push button switch transmitter. This photo shows the front and inside of the navnet terminal. It is easy to see that terminal is made up ordinary commercially available parts and modules. So this is Raspberry Pi and the LoRa module here. This photo is weather sensor, Sense 1502. And this side is the unit for alert call operation. This is a push button switch transmitter. This is receiver. This is a screen of the system monitor PC when alert call is received. Upper row here, who is sender of the alert code, shows who is sender of the alert code. And the bottom row records the time of the alert code processing. Reception time and compression time are displayed here. This is the configuration of the T-factory station. Navnet, this is the same as other stations. And this station has two sensors. One is a weather sensor, the other one is oxygen sensor. The weather sensor measures the atmosphere inside the factory, and also the oxygen sensor senses the percentage of the oxygen in the factory. And we believe this long-term factory data collecting will improve tea activity, tea quality, and productions. This figure is the actual measured by the system in Sri Lanka. Upper is humidity data and lower is oxygen data. This is also actual measured in Sri Lanka. And this one is the numerical data obtained one. This is the oxygen analyzer. Measurement technology is zirconium dioxide. And communication is by RS232C in the chain convert to USB connected sensor navnet terminal. This diagram shows the configuration of the alert call and loudspeaker stations. This station has two Raspberry Pi here and here. The first Raspberry Pi controls the function of the sensor navnet, and the second Raspberry Pi used for audio processing. Text to voice conversion and voice message storage is a function of audio processing Raspberry Pi. The function of this station is to send alert the LFTI key station and audio messages are announced through outdoor equipment for the surround residents. As explained, this station has two Raspberry Pi, here and here. This photo shows the installation of outdoor loudspeaker system, and this is the inside setting condition of equipment. This is the operation screen for sending a voice message from the key station to speaker station. The top view is text message operation. For example, you type in, we warmly welcome you to APAN59 Yokohama. Then this text message sent to the speaker station then will be converted into voice, then announced from the loudspeaker equipment. However, there is no standalone Sinhala language conversion software. So at the moment, we are using English version. The bottom is select voice message operation. The AO2 is the code of the message, which has been stored in the advance in the audio processing Raspberry Pi with VDG audio format, and then this message playback. This diagram shows the water level sensor station. I think if you look at this diagram, no explain is needed. The right diagram, water level rise up like that. The floating sensor switches from on to off, depending on the level of water. Then for sensors on or off, data is transmitted every 1 minute. This is a photo of river water level sensor navnet terminals. In the this photo shows the installation of the water level sensor station in Sri Lanka site. Antenna here, solar panel here, and equipment inside this house. The left photo, the right photo is the internal structure of the sensor. Water level rise up, then this float up, then switch on to off internal magnet switch. This displays the result of manual test of the manual test. The graph shows the water level rising, and then following over the time, like that. This is a photo of evaluation test at NICT, Dr. Owada's laboratory. All of the equipment to be shipped to Sri Lanka, terminals, oxygen sensors, so on, were brought in for this test. The NICT Kongane laboratory is located in the dense forest as shown in this photo. The forest is similar to the local environment in Sri Lanka, so we conducted communication test here. The results are shown in this diagram. The position here, number 2, similar location to the Sri Lanka site. The reception signal here from the key station was about minus 110 dBm. The key station is located here. An engineer who visited the Sri Lanka site stated that the density of trees was lower in Sri Lanka site, and the minimum reception sensitivity of the LoRa module is approximately minus 123 dBm. So we had feelings that we would be able to communicate in Sri Lanka as well. Now, the system is working in Sri Lanka with good radio communication link. A wonderful handover ceremony was held in Sri Lanka on February 28 this year, only 1 week ago. The ceremony was attended by the President of Sri Lanka TRC and APT officials, Vietnam officials, and Dr. Owada. We hope that this system will contribute to the creation of a smart village in Sri Lanka. Finally, we expect our gratitude to APT and TRC for promoting and supporting this project. And likewise, we deeply appreciate the support of everyone listed here. In particular, I express my deepest gratitude to Dr. Owada. Thank you very much, Dr. Owada. Thank you very much for your attention.
Thank you, Gunji-san. And I am the core member of this project. And so do you have any questions and comments, please? So, okay. Oh, okay.
I have a question on the LoRa mesh. So which kind of a protocol that you use is mean LPWAN, or you use like a layers one on the LoRa for making the mesh?
Yeah. Thank you for the questions. And this time we developed we use the private LoRa modules, and we developed the TDMA-based medium access control mechanisms into the original one. So, and the Mac frame format is also original. So,
you develop on your own communication part.
So, and the module maker provides the serial interfaces to send and receive
the data to the LoRa modules.
And we implemented such data transmission timing as a TDMA.
Okay. So I haven't checked for maybe I missed something. So I just want to know about the performance. That means the distance between, first question is like the distance between the mesh node, and also is that being multi-hops or can?
Yeah, in the real field installed in the Sri Lanka, that range is around 1 kilometer, so a relatively small area. So it can receive almost most node can communicate directly, but in some area is over the mountains, so it's a little bit difficult. So we install the relay stations on the top of the mountains, and we relay to reach the data.
Okay. Thank you.
So how long the distance between other relay to other nodes?
Maybe less than 1 kilometers, but
Altogether, right?
yeah.
Oh, okay.
But the line of sight is a little bit needed to communicate each other, because it's the real install situation is for like a jungle. So even the distance is not so far, but the signal level is going down. But the top mountain installed on the mountain node can receive the all signals. So the line of sight is a little bit important.
A very small question, like that what we are going to implement in Nepal is a similar one, yes?
Yes.
Okay. So we are looking forward.
But yes, maybe the next session, Abhimani-san will present the next project. And that project is not using the private LoRa, but also using the LoRaWAN technology to integrate ours.
LoRaWAN,
Yeah.
Almost.
Okay, so it's almost past the first session time, and let's close the this sessions. And thank you very much for Gunji-san about your presentation. And
Thank you very much.
Okay, let's close the first session, and the next session will start at 3:30 p.m. Okay, please join the next sessions.